Hi, my name is Miguel, and this is my reflection for my core activity, RBC Smart. So, first of all, what is a polygon? A polygon is a geometric figure which comes with three or more straight lines and angles, but we usually call a polygon something that has five or more angles. A filling is like a surface that is covered with geometrical figures. Some of the polygons that we used during this activity were the octagon, the heptagon, and the nonagon. And the difference between perimeter, area, and volume is basically that they are like the space they need for something, but the perimeter is in one dimension, the area is in two dimensions, and the volume is a three-dimensional figure or thing. Then what is an apotheme is and what is it used in the figures? Well, an apotheme is from the center of a side of a figure to the center of the figure, and is used to calculate the area and, well, for that also the volume of regular polygons. Then what data do we need to calculate the height, the area of a triangle, a square, and an hexagon? Where for a triangle we need the base and height, so the area will be base times height between two. Then the square will be side by side, and for the hexagon it will be the apotheme times perimeter. This only works in regular polygons, but that's what we are seeing right now. We don't see like irregular polygons, so that's how you get it. Well, how do I justify the perimeter units being linear, the area units being square, and the volume units being cubic? Well, this is really easy. The perimeter is linear because you only are measuring like one thing, so it's only one dimension. You only have like base, that's all. In the area you have two, you have base and you have width, so you have two, then it's square. And in volume you have three because you have base, width, and height, so you're measuring three things, and that is why it's a three-dimensional figure. Then how do you calculate the width area in each tessellation? Well, this is like really easy. I think you just have to get like the area, like for example of a, if you have like a square and inside the square you have like an hexagon, you just get the area of the hexagon, you subtract it to the area of the square, and that's how you get the wasted area, the area that you are not using. Then if I only have one side of a square, could I find the area of the perimeter? Yeah, because every side of a square is like equal, so you only need, for exclusively a square or a cube, you only need one side to get like perimeter, area, or volume. Does the result obtained in the problem match with you found in the research? And yes, I think that the problem is like the bees use hexagons, and this is because the hexagon is a figure that doesn't occupy like too much perimeter to be created. In this case, the wax that the bee use, and it doesn't waste space. Like you can put a lot of them together and you won't waste space. So that's why bees use them, and that's what we get in our problems, and that's what we look in our research. After that, when we use the two-side figure, the two-side figure is called, wait a second because I have a difficult name, a diagon. And we don't use a diagon because like one side of the, both sides of it will be have to be like curved, so it won't be like the surface will be like have like a space under, and it's really a weird figure, and I don't think we can do that like physically, so that's what we don't use it. And what is the other question? Why wouldn't use the infinite side figure? Well, I think this is pretty obvious. Like, why wouldn't use it? It's called an apeirogon, and which is like an infinite side figure, which I understand is like, it's like a box with a lot of figures inside of it. It's really weird, and it's a two-dimensional figure, not three-dimensional, just two-dimensional, and I think we don't use it, first of all because it's two-dimensional, so like in real life we don't need that. We can use them and we can do it like physically. It's just a theoretical figure, so it actually don't really exist in real life, so that's why we don't use it. So another question we have to answer is why the figures with two sides and infinite sides are not considered polygons. This is really easy. A polygon can have a rounded or a north straight line, and a diagon, as you can see, both sides or one will have to be rounded so the shape can form. So that's why it's not a polygon. And well, the one of infinite sides is like a big circle with small figures inside of it, so we have a lot of round lines, and that's why we don't consider that as a polygon. Then what tasks do you consider the ones that you performed the best? Well, I think like I didn't struggle with anything. I did the problems really good. I think that's like I do the best. I have a little bit of trouble like with the Apple theme at the beginning because I didn't know what that was, but when I just Googled it up and it was easier from that point to until the end. So I think like the formulas and that stuff is like. And for the last question, that is basically like if we need to reinforce anything like in our group to achieve our goals, I think that everything went really well. Maybe we miss a little bit of communication, but I think that that's because of we are online and that stuff, and we have trouble with the internet sometimes, or we don't have time to work at the same time, and yeah, maybe we miss a little bit of communication, but at the end of the day, we work together and we get the work done. So I think that there's nothing actually that we need to reinforce for the next time. So thank you.